For this section, we'll be talking about the sum and difference identities for sine, cosine, and tangent. So the sum and difference identities talk about when we have two angles added or subtracted within cosine, sine, or tangent. To begin with, we'll go ahead and talk about the sum and difference identities for cosine, which say that cosine of theta plus alpha is equal to cosine of theta times cosine of alpha minus sine of theta times sine of alpha. And if we have cosine of two angles that are subtracted, theta minus alpha, then we get cosine of theta times cosine of alpha plus sine of theta times sine of alpha. So notice that these two formulas are very similar. The only difference is when you are adding two angles within cosine, you subtract in the formula, and when you are subtracting two angles in cosine, you add in the formula. So, with that, we can recall where this formula has been used in the past when we've talked about cofunction identities. We said that sine of theta is equal to cosine of 90 degrees minus theta. But we never really had a reason why that was true. We could plug in a bunch of angles and it would be true, but why? And now we can show why. Cosine of 90 degrees minus theta is a difference identity for cosine. So let's go ahead and use the cosine formula. So cosine of 90 degrees minus theta, according to our formula, says we are going to take cosine of the first angle, which is 90 degrees, and multiply that by cosine of the second angle. Don't get confused by the theta appearing twice in here. Just remember first angle, second angle. First angle, second angle. So we have cosine of 90 times cosine of the second angle, which in our case is theta, plus sine of the first angle, which is 90, times sine of the second angle, which is theta. And if we simplify this, cosine of 90 degrees is 0. So it doesn't matter what cosine of theta is because this entire term will become 0. Plus sine of 90 degrees is 1. So we get 1 times sine of theta. So in total we have 0 plus 1 times sine of theta, which just gives us sine of theta. And this is our proof for the cofunction identity we had in the past. Sine of theta equals cosine of 90 degrees minus theta. Okay, now to actually explore some problems where we are given values and we need to solve. So we're given sine of theta equals 4/5 and cosine of alpha equals negative 2/5, such that theta and alpha are in quadrant 2. Remember this symbol, this curved looking capital E, just means in or within. So our two angles are in quadrant 2. With all of this, we want to find cosine of theta minus alpha. So how would we go about that? Well, cosine of theta minus alpha, we should write out its formula first, which is cosine of theta times cosine of alpha plus sine of theta times sine of alpha. And now that we have this, notice that we already have sine of theta, which would go here, and we have cosine of alpha, which will go here. So let's plug these in. We have cosine of theta times cosine of alpha, we know is negative 2/5, plus sine of theta, we know is 4/5, times sine of alpha we're still looking for. So once we find cosine of theta and sine of alpha, we will have cosine of theta minus alpha. So how could we do that? Well, there's a couple of ways. The first way is we could construct a triangle. So let's go ahead and do that for cosine of alpha. Let's make a triangle. We know that alpha is in quadrant 2, which means our terminal side is in quadrant 2. So, remember, you always connect the terminal side to the nearest x-axis to create your right triangle. And now that we have this with our angle alpha, cosine of alpha equals -2/5 means the adjacent side has to be -2 and the hypotenuse has to be 5. So how can we find the opposite side? Well, with the Pythagorean theorem that says you take the hypotenuse and square it, and that's equal to the adjacent squared plus the opposite squared, which we'll just call b. So solving this, we get 25 equals 4 plus b squared. Subtracting 4 from each side gives us 21 equals b squared. And taking the square root of each side to solve for b, we get b equals plus or minus the square root of 21, but we already know which one to pick because we want the positive y value. Since it's in quadrant 2, y is positive, so we just take the positive square root of 21. So since this is the y value of our triangle, or the opposite side of the angle alpha, we now know how to find sine of alpha. Let me go ahead and copy this 4/5 down. Sine of alpha is equal to the opposite divided by the hypotenuse, which means it's equal to the square root of 21 that we just found, divided by the hypotenuse, which is 5. And that's plus this -2/5 times cosine of theta. Now, how can we find cosine of theta? Well, again, we could construct another triangle, but I'm going to go ahead and show you the other choice. The other choice is to use our Pythagorean theorem, which says we take cosine squared theta plus sine squared theta, and the result always has to equal 1. So since we're solving for cosine of theta, we're going to plug in sine of theta, which is 4/5. So we get 4/5 squared, since it's sine squared. And now it's just a matter of solving for cosine theta. We get cosine squared theta plus 16/25. That's what we get when we square 4/5. 4 times 4 is 16, 5 times 5 is 25, is all equal to 1. When we subtract 16/25 from each side, we get cosine squared theta is equal to 1 minus 16/25. Well, 1 is the same thing as 25/25. Remember, 1 is anything divided by itself. So 25/25 minus 16/25 gives us 9/25. So to solve for cosine of theta from here, we'll just take the square root of each side to get cosine theta equals plus or minus the square root of 9/25 Well, we can break that up as the square root of 9 over the square root of 25. And that will give us cosine of theta equals 3/5. And we need to decide, do we want the positive or negative value? Well, because theta's in quadrant 2, that means cosine has to be negative. Let me go ahead and rewrite that. There you go. So we can plug that in for cosine of theta here. Negative 3/5. And now it's just a matter of simplifying. Negative 3 times negative 2 gives us positive 6 over 5 times 5 is 25. Plus 4 times the square root of 21 over 5 times 5 is 25. And now we can combine them together because they have the same denominator. We get 6 plus 4 square root 21 all over 25. And that is cosine of theta minus alpha. Okay, so continuing on from here, we now have some, I don't want to say easier, but a little bit easier problems dealing with these sum and difference formulas for cosine. So for this one, we want to find cosine of 5 pi over 12. 5 pi over 12 is not one of the unit circle angles that we needed to commit to memory, but there is still a way we could find an exact answer for it. And we can do that with these sum and difference identities. The first thing we should note here is we have 3 angles in radians besides our quadrantal angles that we can typically deal with. We have pi over 6, pi over 4, and pi over 3. If you're using a sum and difference identity, then typically these are the 3 that you're going to be dealing with, rewriting this 5 pi over 12 in terms of these being added or subtracted. So, if we're going to do that, then we should probably get the correct denominator. So, we need to rewrite pi over 6 with a denominator of 12. Well, how can we do that? Well, we have to multiply the top and bottom of this fraction by 2. Likewise, for pi over 4, we have to multiply the top and bottom by 3. And for pi over 3, we need to multiply the top and bottom by 4. Which ends up giving us 2 pi over 12 for the first fraction, 3 pi over 12 for the second fraction, and 4 pi over 12 for the third fraction. Now that you see these 3, can you think of a combination of them added or subtracted that would give you 5 pi over 12? Well, hopefully you can see that we could change this to cosine of 2 pi over 12 plus 3 pi over 12. That's just another way of saying cosine of 5 pi over 12. Which means, simplifying this is really cosine of pi over 6 plus pi over 4. And now that we have it rewritten like this, we can apply the sum identity for cosine. Remember, our sum identity for cosine says cosine of, and I'm just going to use x and y for this. So cosine of x plus y is equal to cosine x times cosine y minus sine x times sine y. So, cosine x means cosine of the first angle, which is cosine of pi over 6. Times cosine y is cosine of the second angle, which is pi over 4. Doing the same thing for these other two, we have minus sine of pi over 6, the first angle, times sine of pi over 4, the second angle. And now it's just a matter of simplifying. Cosine of pi over 6 is the square root of 3 over 2. Cosine of pi over 4 is the square root of 2 over 2. Minus sine of pi over 6 is 1/2 times sine of pi over 4 is the square root of 2 over 2. And now we begin simplifying. The square root of 3 times the square root of 2 is the square root of 6 over 2 times 2 is 4. Minus 1 times the square root of 2 is the square root of 2 over 2 times 2 is 4. And simplifying this, we get the square root of 6 minus the square root of 2 all over 4. That is the exact value for cosine of 5 pi over 12. Okay, so now with that in mind, I want you to take a moment, pause the video, and see if you can't find the exact value for cosine of 15 degrees. Okay, so trying this together, we can rewrite 15 degrees two different ways. The first way is we could rewrite this as cosine of 60 degrees minus 45 degrees. Or you could rewrite it as cosine of 45 degrees minus 30 degrees. Either way is perfectly okay and will result in the correct value. So, going through this, for our formula when we are subtracting with cosine, we have cosine of the first angle, 60 degrees, times cosine of the second angle, 45 degrees, plus sine of the first angle, 60 degrees, times sine of the second angle, 45 degrees. Which gives us cosine of 60 degrees is 1/2 times cosine of 45 is the square root of 2 over 2 plus sine of 60 degrees is the square root of 3 over 2 times sine of 45 degrees is the square root of 2 over 2. If you had done this with 45 degrees and 30 degrees, then cosine of 45 would give you the square root 2 over 2, and then cosine of 30 degrees would give you the square root of 3 over 2. Combining those two things that we just said together, your first term would be this one. And then likewise, you would have sine of 45, which would give you the square root of 2 over 2, and then you'd have sine of 30, which would give you 1/2, meaning your second term would be this one. So if you chose 45 and 30 as your two angles, then you would still have these two answers, but they would be flipped. Your first one would be the second one, your second one would be the first one, but since you're adding, it's the same thing. 1 plus 2 is 3, 2 plus 1 is still 3. Okay, simplifying from here, 1 times the square root of 2 is the square root of 2. 2 times 2 is 4. Plus The square root of 3 times the square root of 2 is the square root of 6. Over 2 times 2 is 4. And simplifying this, we have a common denominator, so we just add the numerators, which gives us the square root of 2 plus the square root of 6, all over 4. And that is cosine of 15 degrees.